think we can start, right? Yeah, I think we can start. Okay, hello. Good afternoon, everybody. Welcome to the second panel in the conference. This panel on architecture will be moderated by Ömer Bulakci. Ömer is leading the core network architecture research in Nokia and the standardization team. He is the chair of SNS EuCNC architecture working group, and he was previously working in Nokia also as the CG program, and has contributed to LTE, 5G, and all the technologies coming to here to 6G. He's presenting, he will be introducing the panelists. So I pass just the micro to you, Ömer, the paper.
Yes. Okay. It's okay? Okay. Good. Thanks a lot, Pedro, for the nice introduction. I mean, there was actually a glitch. The name of the panel was Sustainability Outside. But as you see, we haven't turned off the lights, so it is clearly not a sustainability panel. But we were promised that it is low energy LED lights, so I think sustainability colleagues are also fine with that. So I'd like to first a bit set the scene for our panel. Architectural transformation towards 6G. We will talk about the standardization aspects, the landscape of standardization, the enablers, challenges, and so on. I have a great panel here with our colleagues. They accepted the offer to come and become part of the panel. And then, of course, I will introduce the panelists later on. Okay, let's first a bit look into the key considerations for architecting the future wireless networks. Whenever we move from a previous generation to next generation, of course, the first thing that comes into mind is the performance, right? So we are striving for a performance 6G system. So we are driving for performance, network efficiency, innovations that enable the increased performance. And also we look into the new spectrum bands overall, how to make the 6G system performant. Intelligence, this has been the focus of the conference so far, you know, like how we can make use of AI, how to integrate AI, how to make it an integral part of the 6G system. So making really a network's intelligent 6G system intelligent to even help AI innovations on that sense. And also introducing new services, enhancing the connectivity and so on. Sustainability, of course, is a critical key consideration for the 6G system. This was like from the early days of the 6G research, we said that, okay, sustainability should be a design criterion for the architecture. And this supports, of course, the low carbon circular future and also fosters the equity among the people on Earth. And secure and cyber resiliency, we introduced new innovations. We talked about, for instance, the risks that can be associated with these innovations when we integrate AI, about the guardrails and so on, and the new innovations such as the rise of the quantum computing. So the 6G system should be secure and cyber resilient in that sense. So if you briefly put the 6G system as an AI native 6G into the center, the intelligent networks, some key, let's say, ambitions that we are striving for when we reach the 6G system. Under the performance consideration, of course, looking into the capacity improvements, and these are the ambitions we have on the uplink side and the downlink side with enhanced MIMO schemes or having, for instance, additional spectrum on the upper mid-band, looking into new mechanisms for CSI acquisition and so on, so to really improve the capacity overall. This also comes with the ambition to improve the coverage on the uplink side, particularly on the cell edge, where we can think about link budget improvements in terms of like power increase or improving the mechanisms such as the multi-slot transmissions. Then with the 6G era, we also look into supporting diverse devices from low end to the high end, and would like to have a scalable design so that we are looking to more and more modularity and how we can basically support this diverse set of devices. And we have heard in the keynotes before throughout the conference, there is an existing investment. We would like to, of course, consider the existing investment. That's why we think 6G should be smooth, let's say, upgrade on top of the 5G standalone. For the sustainability, some requirements from the energy savings, such as improving the network energy saving by 40%, where we can look into the cases like turning off the cells or beams, going into more linear carrier frequency carrier design. And on the device side, the ambition is to increase the modem standby, where we can have mechanisms like clustering the user plane data, and to increase basically the discontinuous reception and transmission on the device side. And as discussed before, for secure and cyber resiliency, having the crypto that is quantum resistant, take into account the risk that may come with the new innovations such as AI, to have the guardrails, and also strengthen security on the lower layers such as the radio security. With that, with every generation, we have always this question, right? What is the killer use case? What is the killer app? So we are always hunting for a killer use case that will really prove us that we need a new generation, right? So what is the key characteristics of such a use case? Like on one hand, it should stretch the network capacity so that, you know, like we justify the need for new enablers. Then it should reach a widespread use, so that not only maybe humans and also machines would like to use that application. So we need a ubiquitous access in that sense. And it should solve critical problems. So it is in terms of the societal and business needs. So have we found a killer use case? This will be a tough question in the panel. But just to give you like one experience just from my end, maybe picking the best watermelon with generative AI could be one interesting use case. So this is to see, you know, like how we should think outside the box. This was a photograph from my road trip in Turkey, and there was a young man. He said, ChatGPT is the best watermelon picker. So, and we tried to really pick the watermelon with, I'm using Gemini, he's with ChatGPT and so on. But if you think about this, it is actually clearly, it stretches network capacity. We are trying to upload the pictures, you know, like trying to, you know, overload the system. We had issues in terms of coverage. We couldn't have real-time selection because we had coverage problems. And I think I would argue that in certain countries it's a societal problem, especially if you don't bring the best watermelon. So if you look into if you're curious about the selection, that was the Gemini's pick, and that was the ChatGPT's pick. And as I said, this was last year, just before the conference, I said how the AI improvement is. I had some problems with hallucination, prompting, and so on, but just before the conference, simple prompt, Gemini just gave the first pick, best pick, and even I didn't ask, gave the second pick. So huge improvement, I would say, compared to last year, but of course, I had also good coverage. So the use of generative AI by humans or the machines, the robot taxis, and it could be another example, imposes additional network requirements. So you see here on the right-hand side the data consumption measurements in our Nokia lab. We particularly looked into different use cases and data usage. And then you see that here, especially on the uplink side, the device AI increases the network traffic, and particularly on the uplink side. I think it's also justified with our ambition to improve uplink. So how do we reach to the 6G system? What I call three-phase approach. On one hand, the pre-X. Most of us in research projects, we were part of the pre-X. So you can put competition, standardization, or commercialization instead of X. So this is the exploratory phase where we try to find the killer apps, we try to define the requirements, and so on. Second phase is the standardization, where we need a well-rounded feature portfolio for day one of 6G. And what I call, we need to also strive for architecture-driven design. So to minimize the number of options, this is a lesson learned from 5G, and we strive for a global standard. Commercialization, it will be part of release 21, so which the functional freeze will be end of 2028, so you can assume that around 2029, the specs will be ready, and then we can expect the deployments as early as in Q4 of 2029. And 6G should respond to business and societal needs beyond 2030, that's important. So overall, executing all the phases, we can reach the realization of 6G system, and currently we are at the phase 2. With setting the scene, so here we have our, our panel. We said, okay, we look into the key aspects of the 6G system. We look into, how the architectural transformation towards 6G will be, and we collected our panelists here, and we will give you some updates on that regard. So for the rest of the panel, so first, We will have each panelist giving you a concise presentation that will touch upon some of the key questions we have, and then we will proceed with the panel discussion. With that, I'd like to first call Nakamura-san, so we can open the first presentation. So Mr. Takehiro Nakamura joined Entity Laboratories in 1990 and is now Chief Standardization Officer at Entity DOCOMO. He has helped advance wideband CDMA, HSPA, LTE Advanced, 5G and 6G through leadership in R&D and standardization. Since 1997, he has contributed to ARIB, ITU, and 3GPP, serving as Vice Chair and Chair of 3GPP RAN from 2005 to 2013, and he has been a leading force in promoting 5G and 6G in Japan as well as internationally. He currently leads local 5G millimeter wave and 6G projects in XGMF in Japan and serves on the board of 5G ACIA and is a sub-leader of Human Augmentation Consortium. I'd like to give the floor to Nakamura-san.
Should I talk here?
You can, as you wish. You can also.
Anywhere. Okay. Okay. Yeah. Thank you very much, Ömer, and thank you very much for having me to this great event. Okay. So I'd like to explain our Entity DOCOMO's views on the 6G network architecture and the AI-centric network. But before providing my company's views, I'd like to explain this slide. This slide is developed by the XEMF, XE Mobile Promotion Forum. That is a 5G, 6G promotion organizations in Japan. And I'm deeply involved in the XEMF activities, especially for the 6G topics. And this is a very, very high-level summary of the design principle of the architecture. From the 5G to 6G, important point should be a simplified, modular, and cloud-aligned 6G architecture. AI-driven autonomous operation and the convergence of computing and communication. These are the very, very important points to migrate from the 5G to 6G. Okay, so this is a very high-level summary of the XEMF network discussion. From here, I'd like to explain the DOCOMO's vision. And yeah, this slide showed our vision of the 6G, values of the 6G. We identified 5 values of the 6G on top of the AI. So AI is a very big baseline foundation of the 6G. That's a 6G native manner. Especially AI-centric network, AI-native network. We have 2 aspects, as you know, the network for AI and AI for network. Network for AI, of course, our network should be optimized and improved for the coming AI services for the future. And yeah, of course, higher performance, including the higher data rate, low latency, and so on. And also in the computing aspect, maybe our network should have a good computing resources, computing functionalities for the variety of the AI services. And the AI for network, our network can be operated very, very efficient manner thanks to the AI technologies. We are already introducing a variety of the AI technologies for our O&M, or operation and maintenance of our network already, even in the 5G system. But toward the 6G, more excellent features will be implemented, introduced for our network operation. And I would like to explain some of them, our activities, network for AI. For example, sensorless robot. Currently, many of robots have many sensors and many capabilities like cameras, and expensive and heavy. But if our network can support the sensor and the camera on behalf of robot, maybe a robot can be much lighter, smaller, and cheaper. So this is our concept of the sensorless robot. We have already developed some kind of the experimental robot to verify the sensorless robot use cases. And in network computing, some of the devices like XR devices, performance, processing power is very small. So network has a very big computing resources, and the network can support the process computing of the device side in the network side. So this is a network computing concept. Next, AI for network. Yeah, and 6E, as you see, 6E will integrate optical and quantum computing into the network, enable autonomous operation, extreme reliability, and data-driven service optimization. Especially, we see that very, very important for the network operation point of view. As you can see, 3 topics: zero human error, zero outage, maximize user experience. So AI can work for all of them. And also, this slide showed our thinking on the portfolio of the AI for network toward the 6E. Not only RAN, but also core network operation O&M side, and also non-real-time, real-time. Yeah, many features can be considered. And the green part, we have already treating and developing some experimental system and trials. And yeah, many of them showed a very good performance improvement and benefit thanks to the AI. Yeah. Okay, so maybe I should stop my presentation, maybe. Yeah, thank you very much for your attention.
Thank you very much. So next, our panelist is Dr. Alain Mourad. So he's a Senior Director and Head of Wireless Labs Europe at InterDigital, where he leads advanced wireless research and innovation. He has led senior roles at InterDigital, Samsung Electronics, and Mitsubishi Electric, not at the same time, as opposed to the website, and contributes actively to the global research and standards bodies. He serves on ETSI board and chairs the ETSI ISAC Industry Specification Group. So, Alain, the floor is yours.
All right, thank you, Ömer, for having me, and good afternoon, everybody. So I will, before I delve into what actually might lead to 6G architecture transformation, so I decided that we take a bit of a step back and see where are we today with that journey towards 6G. So I always like actually to look at that journey as a marathon rather than a sprint. But that marathon actually already kicked off or started, and it is indeed picking up speed with a number of milestones along that journey. So the very first milestone I think worth highlighting here is the ITUR IMT 2030 framework that was completed back in 2023, right? And the second milestone, which also from ITUR, completed as recent as a month or 2 months ago, with the completion of what we call the minimum technical performance requirements. Now, what we are looking forward to as the next important and major milestone is actually next year, with the completion, hopefully, of the 3GPP Release 20, with really 2 streams in that Release 20. There is the 5G Advanced stream, and there is the 6G stream. So why is this important, actually, is because 6G will be building upon 5G Advanced, and actually the enhancements that we are bringing into the architecture already in 5G Advanced will continue its way into 6G. And also the 6G study that's happening in the Release 20 will be actually laying the foundation of what the architecture is going to look like in the follow-up, very important milestone, which is end of 2028, which will see actually the completion of the Release 21. And the significance of that Release 21 is it's going to be the very first 3GPP release that will have 6G specifications, right? So if we were actually to fast forward towards end of 2028, so this is when we're going to know actually what architecture 3GPP will decide for 6G. Once we are done actually with that important milestone of end of 2028, so this is when the ball is going to actually come back to the court of ITUR so that they evaluate the proposals that are coming towards IMT 2030, so that next in 2030, right, when they're going to be making the recommendations of the radio interface technology for IMT 2030. So as you appreciate from here, so there is already quite a number of milestones met, but there is a lot actually in progress, and the journey is really picking up speed. Now, delving a little bit more into the 6G architecture, so what's actually making that architecture pretty appealing or, anyway, exciting, right? So first of all, it is worth, I think, echoing what Nakamura-san kind of hinted about earlier on the design principles. So we don't see actually 6G making a significant shift from 5G on the design principles. So we still actually see 6G architecture based on the service-based architecture principles that were already actually laid down in 5G. But what's really going to be interesting on the 6G architecture are, at least in my opinion, 4 key topics. The first topic, which is obviously my favorite, is sensing, right? Why is it my favorite? Because I also wear the hat of the chair of the ETSI ISAC Industry Specification Group. And the way actually we look at ISAC is really broader than just actually enabling that capability of sensing, RF sensing in the network. Really the opportunity that we see in terms of impacting the architecture is in the sensing data and the ability to get that sensing data from multiple sources, get it into the network and do something useful with that data actually. So it's really ISAC from the angle of the observation data or observatory data, especially around the physical world. Next, and needless to say, is obviously AI and data, right? So which is going to be actually as Nakamura-san outlined earlier, right? So AI will be helping the network, and that's what we are seeing already, the kind of work in progress in the 3GPP by defining use cases where actually the network can actually benefit from AI. But also importantly is that actually the network for AI. So we are seeing the network being actually the platform that's going to be allowing and enabling the AI traffic, the new AI traffic, and all these AI applications. Also important to add actually here is the role of edge computing. I mean, one would say edge computing, it's an old kind of tech now, but it is making a comeback, and that's going to be playing an important role in the architecture design of 6G. Why is that? Because obviously you are hearing of physical AI and the need actually so that we process data closer to the source, right, and then allow for fast inference, right? We don't want to send all that observability data through the network. So edge computing is going to be actually playing an even more important role now in defining, the 6G architecture. And last here, but not least, is really when we talk about the tokens, because when we talk about AI, it's all about, tokens, right? And tokens is the currency of AI, as we say it. In the same way as we actually thought about the bits and the bytes and the gigabytes being the currency of 5G or 4G or 3G. So this is now all about the tokens and the ability to monetize actually all this AI traffic and the AI services through tokens and bringing a form of accountability, especially when we are automating actually the network, through these tokens. So in a nutshell, I see actually ISAC, AI, edge, and tokens being, really key technology topics that will be driving, if you like, the enhancements that 6G architecture will bring on top of the 5G architecture. And if there is something actually in common across all these 4, is actually data. But I will leave my comment on the killer app in connection with the data to when actually we start the discussion. So with this, I thank you for your attention.
Thank you very much, Alain, for the pitch. And the next panelist is Dr. Patrik Rugeland. So he's a master researcher at Ericsson Research in Stockholm, focusing on radio network architecture, protocols, and standardization from LTE Advanced NR towards 6G. He served as a technical manager of the Hexa-X and Hexa-X2 projects and holds more than 90 patents. He also co-edited 2 6G books and leads the 6G IA Vision and Societal Challenges Working Group. So, Patrik, the floor is yours.
Thank you, Ömer. So I guess all of you heard Magnus Frodig's keynote the other day discussing Ericsson's vision for 6G. So I will instead focus on some open questions for architecture. And no discussion on 6G can go without discussion on AI. So some of the open technical challenges for AI. One is, of course, the trade-off between hardware and performance. We all know the amazing things AI can do, but what are the costs of actually deciding or get the AI to do this? So is it worth placing extra hardware to get a small improvement? Sometimes it is, sometimes it's not. Another open question is, how do you integrate it with existing infrastructure and existing system without interfering with their operation? Security is, of course, an important question. Does this open up new attack surfaces? But I also have the question of predictability. Can we trust that the AI models does what it's supposed to do and always fulfills the SLAs and don't hallucinate and mess up everything? And to do this, we need, of course, lifecycle management of the AI models throughout the entire lifetime of the AI models. And if we look at how can we standardize the AI model, and especially for agentic AI, from Ericsson, we see AI mostly as an implementation technique. The benefit from agentic AI is mostly on the higher layers. On the lower layers, the performance are really good, but but on the higher layers, there are more problems to be solved. And to standardize this, we need to make sure that we don't standardize too rigid interfaces, don't lock into a specific implementation, especially since AI is developing so fast compared to standardization. So if we lock into a solution today, maybe we'll look into a specific semantic, the specific policies, solution, or security. But for instance, in 3GPP now, there's discussion in SA2 to introduce an AI domain in the core network. But let's see what 3GPP decides. But on the other hand, we have these open source protocols. We have the Anthropic Model Context Protocol, as well as the Google's A2A protocol that are available now. And we don't know what will come in the next couple of years. But can these protocols be directly used in the mobile networks? Maybe not. They both assume that at least the consumer side has an LLM, and not all systems may require this. But moving on, so 6G will be more than AI. We will have these beyond communication services. For the communication service, the architecture will likely look similar to 5G. We'll have a little bit more exposure, a new RAN, an evolved core network. But when we look at these beyond communication services, for instance, sensing, this will require some new interfaces, new functionalities to control the sensing functionalities, collect the data, and distribute the data. And for end-to-end, there's a question on if we have a transparent or regenerative architecture. For edge computing, we can see many different use cases. Some of them are AI-based, many of them are non-AI-based. For the non-AI-based use cases, such as extended reality, these are often very time-critical, so you need the compute very close to the user. Whereas many of the AI use cases, the inferencing takes a dominant part of the latency. So there, it's not as important to have it very close to the user. And we can see edge computing in 3 different scenarios. You have the on-premise compute, where vertical has both the devices and the whole network and the compute. You have the operator edge, where you integrate compute functionalities in the mobile network. And you have, of course, the public edge with the over-the-top services. And so far, we don't see any clear demand for use cases for the operator edge. Hopefully, there will come up a few in the coming years, but today, we don't see a clear motivation. Of course, for the on-prem, there's a clear need, and over the top, we already see big usage today. And finally, a big improvement in 6G will be the exposure. So you will expose many parts of the network on many different levels. On the lowest level, this will mostly be internal to the operators, exposing both data and different capabilities. But as you go higher up in the layers, you will start exposing different services, aggregating services from many different operators, or for a specific vertical industry. And an open question for exposure is, today we expose towards a human developer, but does this need to change once we start exposing towards an AI agent? And that was quick summary of mine.
Yeah, thanks a lot, Patrik, for this presentation. Next on, we have Dr. Diego López. He's a senior technology expert at Telefonica, where he leads technology exploration within the CDO unit. His background spans academia and industry, with research in digital identity, computational intelligence, and network services. He focuses on network infrastructures, quantum communications, and data infrastructures, and is an ETSI fellow and chair of the ETSI Technical Committee on Data Solutions. So, Diego, the floor is yours.
Thank you, Ömer. Well, when thinking about the participating in the panel and all this on the architecture of future networks, I came with the idea that has been repeated recently, have heard very much about whatever native network, about the network being native, incorporating things that are associated with, well, what is perceived as a base technology and making the network as part, a fundamental enabler and a fundamental user of that particular technology. That, in terms of architectural principles, to me, looks much more important than whether you draw the line of this G or this other G, because these nativeness conditions are more related to a soft evolution of the network into new features, new mechanisms for providing services, new mechanisms for maintaining, and at the end, for building the services and deriving some income for providing the service and making the whole ecosystem, the whole networking ecosystem, the global networking ecosystem sustainable and able to support future economic growth and wellness in general for humankind. So the idea is how we adapt networks and how we make the network architectures take advantage of this promise of this nativeness, and how we can commit to being native, reach this native state, and contribute to the use of these technologies. And in particular, since I started being involved in this business, that is, in despite of my white head, is not so long ago, because I've been in Telefonica for the last 14 years. Before, I was a customer of telcos and a strong critic of telcos and what they were doing, etc. But well, I am on the other side. Right now, there are three waves that I have been witnessing, and that, well, we have tried to foster. In some cases, even to invent them somehow, and to associate it with standards activities, with research first, and with standards later on, as Ömer was saying in his presentation. And these three waves of nativeness are connected first with cloud native, and those of you who were part of the NFV initiative would recognize this. Despite everything, it has not passed yet. We are still navigating on it. Second is the network becoming AI native. That is something that is right now the hot topic, and we keep talking about what we're going to do to make it native one way or another. I believe that the next big thing that is about making the network quantum native. So, in the first wave, I'm talking about this, is about the first wave has been was conceived as a totally revolutionary one, but as many other ways has proved to be more evolutionary than anything else. The idea is that, we have been adapting the architecture to take advantage of everything that has to do with virtualization, cloud nativeness, the scalability, the flexibility, etc., and trying to mix, and that is very important. When you become native, this is very important, is about you have to adapt the technology to what is essential for the networks. Networks are not clouds. Network have a topology. Network have to be aware even of the geography. Network has to be way more open that, for example, the cloud providers, network providers, we are obliged to collaborate with our competitors. That is something that cloud providers don't, for example. And something that they call the conservation principle is about whatever entering the network has to go out. And this is something that you have to keep a balance that is difficult to keep. So the idea is that precisely we are trying still to incorporate all the principles that are derived from slicing, automation, multi-domain, the building of multi-domain services, and this is an ongoing effort, for sure. Probably the peak of this wave has already passed, but still is influential in the architecture. Second is about the use of becoming AI native, and it has two phases. We're talking about this, network AI for network for AI, but I would like to, apart from what is said in the slides, that probably you will have them available later on, I would like to make a couple of notes that are very important. Especially, and which is highlighted in bold, is that these are the relevant and the common things that networks can provide to support AI should be, and I do believe they are, totally independent of the nature of the concrete AI technology we are using. It would be a big mistake try to adapt network to LLMs or try to adapt networks to the so-called agents right now that, in my view, are LLMs in disguise somehow. It would be not very smart to adapt network to whatever becomes fashionable tomorrow. AI is evolving very quick, among other things, and this is a second consideration, because, for example, they are not supposed to be under 5 nines. Think about what does 5 nines mean when you're operating using AI? Because we cannot avoid 5 nines. We are committed to 5 nines, and if we go away from 5 nines, we are doomed. And this is something that we should not forget. On the other hand, and this is important, is about what networks have provided always, that is openness, radical openness, supporting the possibility that I can choose my piece of LLM, combine them, make them work together, not use this current way of I send something and then somebody is telling me I'm thinking. So I'm playing in that direction. Finally, with quantum. Quantum is it's blooming right now, is starting to become something relevant and important. Is about we have to hybridize. It's not about having a single quantum network that is going to be separate from the other network, the same way that it was not very wise, frankly, to have a separate mobile network that was totally independent of the fixed networks. We're still paying that. It should be, we should try to make them converge. And well, there are 3 principles about being agile, sustainable, and pliable that would be essential for making this. And well, you have there the low-hanging fruit that has to do with security. It's basically about how we address the quantum menace on encryption, but there are many other matters, and this morning we had a quite interesting session in which some ideas were highlighted about things that sound so exotic, like quantum money or teleportation. There is a very strong set of opportunities if we manage to identify how we can hybridize what is existing right now with the evolution of quantum technologies. Well, this is just a list of the projects in which we are involved right now. We are playing with all these ideas here as part of the different programs related to networks, and not so much totally related to networks. We are working on them, and we are trying to address this and to learn which are the principles to make things more whatever native, and making the architecture of networks evolve in those directions. Thank you.
Oh. Thank you very much, Piero. So next on we have Professor Dr. Elif Uysal. She's a professor of electrical and electronics engineering at METU Turkey and founder of FRESHDATA technology. Her research focuses on communication and networking theory with emphasis on energy efficient, low latency communications and non-terrestrial networks. As she is an IEEE fellow, she has received major honors, including an ERC Advanced Grant and the IEEE ACM Infocom Test of Time Paper Award. And she has served on leading editorial boards and is chair of the METU Parlar Foundation for Education and Research. So,
thank you. You've already heard about 6G from this great panel. Wonderful ideas and quite original thoughts have already been spoken. I will be trying to talk about some complementary ideas that represent my own vision of 6G networks. And that vision can be summarized as goal-oriented networking. Now, we find ourselves with 6G at a point where networking is changing because the consumer of the data is increasingly applications and decision algorithms and networks that sense the environment and networks that even can control the environment, like these sensorless robots that Nakamura-san was talking about. Now, when the consumer of the data is machines and algorithms and agents, what does it mean to provide quality of service? My research is focused on goal-oriented networking, which is essentially the concept of getting the data to the point of computation at the right time where it's going to be significant to the computation. If we take this as a new goal, this new paradigm, then the KPIs start changing, the performance indicator. So as in the opening, so performance is the first thing that we expect from 6G, but performance in terms of what? So traditionally for 80 years of digital communication, performance KPIs have been measured in terms of data rate, throughput, latency, etc. But now we are in a position that we can rethink the KPIs, and we are, with the AI nativeness, we are in a position where we can essentially control these KPIs with new tools. How, for example, if one thing that we can control is we can control the rate at which sources generate the data. In the case of, for example, the sensorless robotics, we can have query-oriented data pulling mechanisms from the end nodes. Or for example, when we are running a digital twin remotely that is fed with data that's sent from a sensor, but there is delay in the environment, such as, for example, with non-terrestrial networking. There may be propagation delay that is kind of not even on par with the dynamics of the system that we're measuring or controlling. Then it becomes interesting. We saw in research what sample to pick, what sample to even put on the network, depending on the condition of the network. So that brings us to the new paradigm where data can be controlled. The data generation can be controlled rather than being assumed to be exogenous to the network. So AI nativeness can control this, but of course I need to add a caveat that AI itself should be sustainable in terms of energy. So the way we incorporate AI, the way we incorporate autonomous agents into the network should be to be able to do things that we essentially didn't know how to do before, or couldn't do before, or didn't need to. Now, so essentially, I'm talking about the value-aware network. The value-aware network does not need to send everything, does not need to send the entirety of a flow of data generated somewhere. The control plane may not always be on. The network itself may learn the value of the information, the significance of the information, and sometimes silence itself can be an action. So the network should be able to decide when action is valuable or when silence is better, so that when we, for example, talk about massive machine-type communication, this is possible. It is possible to scale the network. because in terms of spectrum and energy, etc., we know that at the end of the day, we are bound by some resources, some finite set of resources. So, supporting the scalability of massive connectivity goes through some new action algorithms that have judicious use of silence as well. Now, another important thing, important component of 6G is that it is non-terrestrial network native. So this is clearly important for worldwide connectivity. Here we run into this age-old notion of store and forward resurfacing. And it brings with it a lot of interesting unsolved problems. Now, when I say goal-oriented communication, one of the tools we use for goal-oriented communication is related with the timeliness of a piece of information. And timeliness is measured by this metric called age of information that most of you may have heard about, that has been very active in the research community for the last 10 or 11 years. And now, in terms of looking at age of information optimal routing or access, we see that it's quite different from the way we usually do have optimized terrestrial networking algorithms in this environment where connectivity in NTN is sort of sometimes discontinuous. Okay, now again, in terms of radio access for NTN, we are looking at coded random access schemes that are goal-oriented, and this concept of traffic shaping that now we can do thanks to all of this machine learning and AI tools that we have. And talking about edge computing, and edge AI, again, we could go back to what the edge computation is done for. So the local computation should be done for providing fresh decision updates, and the timeliness of the decision is important. So for that, some of the computation, specifically in NTN, could be done in orbit. And I sort of, as a last point, I'd like to make that service level agreements in 6G may move from throughput guarantees to the guarantees such as freshness or significance of the information. So users could buy timeliness rather than bandwidth. For example, we could have age of information defined service tiers such as peak age being upper bounded by 500 milliseconds, and pricing can be linked to decision quality. And these would be natural fits for Internet of Things applications. This is all I have to say.
Yeah. Thank you very much, Elif. So with this, we went through the presentations, the concept presentations from our panelists, and now we will proceed basically the overall panel discussion. Now you see why we have the seat order. So we will basically start with some lead questions, and then of course we will give also the chance to the audience, and you will get some triggers from my side. Okay, so. I mean, the first question, like I think we also have seen, we touched upon in the different slides and presentations and throughout also the conference, is, and also like Diego was mentioning about the nativeness, right? The AI native 6G system, you know, and as we know, in the previous generations, we already started with 5G Advanced, looking into the use cases related to AI/ML, but with 6G, we are talking about the nativeness. And now the one question is, as we are aiming for native integration of AI/ML into the 6G system, as a native component of the 6G architecture, what would be the main technical challenges? What do you think about the main technical challenges to achieve this goal of nativeness? So, any opinion? We can just...
Nakamura-san?
Nakamura-san, you want to say? Okay.
Okay. Hello. Okay. Yeah, maybe we have a variety of challenges, I think. And from my side, yeah, one of them should be, many people mentioned that traffic will be increased by the AI. And operator point of view, of course, we need to prepare the increase in the traffic for the future. And our radio system need to be improved with the 6G technologies, new technologies, and also new spectrum resources will be needed, and that will be implemented. And also, many people say that the uplink traffic will be increased, especially. And the uplink is anytime challenging, but we need to improve the uplink performance for the coming AI. And also, one more thing, in order to utilize the AI technologies well, and we need fresh and correct high quality data from our network side. How to get fresh and good quality data and a timely manner. So far, I heard that it's a little bit difficult to get the data real-time manner. We have some latency, big latency, to get the data from the network side, network equipment. That can be improved, and so that we can get fresh data almost real-time manner, so that we can apply the variety of the new method to utilize the AI, especially for the AI for network aspects. Other many challenges, but maybe for other panelists, I would like to stop my comments.
Yeah, thanks. Of course, freshness of data, you know, it was also mentioned by Elif as an important and different kind of like criterion. Any further opinion from panelists?
But let me say one thing. I mean, it's about the data flows and every data flow. That's very important because we tend to think always about that the data flows are always the source data. Source data is important, then sensors, whatever, but there is when you take a decision, when the AI system takes a decision, that's another data flow. It's, the amount of data is much lower, but it has or should hold the same properties that we are asking for quality, we are asking for traceability, we are asking for a proper identity. In the other direction should be the same. So we can trace, analyze, account, etc., and for sure be able to provide some degree of explainability. Because if something is going to take a decision, we need to find why that decision was taken. And it's not enough to say just because parameter 120 million was out of bounds or whatever. That's not enough. You have to understand how you connect it with the instructions you provide. And second, this is even something that is important. This is for the side of the AI for network. But if we are able to produce this would be an ideal service to be provided to network customers as saying, look, your network is AI native. Your network can justify, can provide suitable data flows, whether it's your data or it's the decisions that are impacting you, and you can consume them. And this is something that could become a quite interesting new service. Probably connected to somehow the edge and the ideas around sovereignty, but not necessarily, but could become a new service to be provided.
Especially, I mean, I think the part of explainability is interesting, right? Because I think during the conference we also discussed about the failures, you know, like What if like an AI agent fails in autonomous behavior and so on? So we need to really understand why the failure was, you know, like, and then also avoid these cascaded failures. Any further touch points from?
Yeah.
Maybe first Patrik and then Alain. Yeah.
I mean, one major challenge with AI is, of course, the processing requirements. It's very energy intensive. You need a lot of hardware. How do you ensure that you can do the proper processing, AI processing at the proper place? How do you get the data close to the user, or should you do it remotely? How should the architecture look to get the best out of it? Maybe AI is not a solution for every problem. How do we determine which problem we are benefiting from AI? And how do we design the architecture for that?
Yeah. Okay, thanks. Alain?
Right. I think the way I always look at 6G is by looking at 5G Advanced being the stepping stone for 6G, right? And AI actually is not limited, obviously, to 6G. We already started the journey of AI already in 5G Advanced. With that in mind, I think there are technical challenges that we are already solving or solved and in the process of solving in 5G Advanced, especially on AI for the network. So basically use cases that we already identified that could benefit from AI. And this, I think, ought to continue by extending or expanding that framework for new use cases in 6G, no doubt about it. But what is actually making, if you like, a big come forward on the challenges of 6G is really this network for AI, right? Where actually there is an explosion of AI traffic, right? Especially with these agents having millions of tokens to handle. And so how does actually the 6G system scale to afford and support, right, this new emerging traffic type that is through all these tokens? So this, I don't think this has been actually touched upon up until now in the work of 3GPP, and this is indeed coming, you know, right on the plate, if you like, of 6G to try to tackle it.
Yeah, I mean, I actually like quite the term you said also in your presentation, token as the new currency. So I think this is, we need to also look into the new mindset change in that regard, 100%. Right? Of course, we'd like to not only discuss among us, if there is, we can take one question from the audience. If you have a specific question related to AI native 6G system, we can give. Yes, one question. Yes. You first come, first served.
It's a question. I'm Rugeland from CDDC, and it's a question very related to what we were discussing. And it's a question basically for the operators, but anyone can contribute. So imagine that you have only one euro to invest in some of the things that you are researching and need research for the future decade. As operators, what will bring you more value in the next 10 years? AI for networks or networks for AI?
All right. So great question to operators. Diego, you want to go first?
If I can, I would say the second. I would try to go for networks for AI. We have reasonably good automatic systems. For sure, AI for networks would help, etc. But I think that for operators right now, it's way better to address our customers, provide new services, try to identify new sources of revenue. Well, we have been quite good in reducing operational costs. So I would go for trying to.
And Nakamura-san, what would be your choice?
Of course, both. Of course, yeah. And network for AI, AI for network, yeah, we have already applied a variety of the functionalities for the O&M, and that will be enhanced and improved more to reduce the cost and, yes, for the efficient operations. And also, yeah, we are aggressively working on the creation of new services based on the agentic AI or other AI, both for the consumer business and the enterprise business. So both. Yeah.
Thanks a lot.
Okay. I think there's.
I think.
Okay, you want to get outside the box?
Not in answer to, in particular, his question, but answer to your answers, maybe, because I think your answers bring sort of a challenge, an architectural, technical challenge to the 6G architecture, because if all of these people using AI over the network are, you know, sharing these giant models and running these LLMs wherever, that provides a big technical challenge on the network provider, right? And how to build that and how to, right? Use the SLAs for that.
And trying to decentralize this would be quite interesting. Not only for operators, I think it would be even interesting for the whole planet, taking into account the energy consumption that we are.
But the network operator sort of has to maybe lead the user on how to do things efficiently. Because otherwise they would be completely taking over the network, right?
That's then we started on the trust relationships and why well, if I can I say that why the Googles are much more much more trustworthy than the Telefonicas. That this is something that to me is difficult to understand, but well, this is what it is.
Yes.
And changing that is it's challenging.
Yeah. Okay. Thanks, colleagues. So if you come back to the slide. So maybe here a pulse check for the audience. So you have heard the discussion. So do you think AI native 6G system shall be the top priority of our ecosystem? If you think that is a yes, maybe you can just raise your hand. Do you believe in the AI nativeness as a top priority? Well, I mean, maybe the audience is against AI. We have to convince still.
They are modern Luddites.
So we will work on that, why we need AI native 6G system. Okay, so the next part of the discussion is about the agentic AI. So it is actually the next level. Let's see if we can convince the need. So, of course, we talked about AI ML, it should be native component and so on. And of course, the next level is the agentic AI, right? I mean, the agents, autonomously working with LLM or without LLM and so on. But this also introduces a kind of like a dilemma, right? Or a kind of like a trade-off, because now in the STOs like 3GPP, we are discussing about how we can integrate agentic AI into the overall architecture. And the standards have, of course, the mandate to ensure interoperability, right? And then if you look into the agentic operation, by definition, we have some stochastic behavior, and then the agents, with LLMs, and so the intents and etc. So there's kind of like a trade-off, let's say, between the interoperability, determinism, and the stochastic behavior. So what do you think, the STOs can enable this agentic AI integration, considering this kind of maybe conflicting, let's say, requirements? So, opinions for that?
I can kick it off. I mean, one of my learning actually at this conference was this nice delineation between AI agents and agentic AI, right? So obviously, with AI agents being looked at, in silo, and what the requirements are in terms of input, output, right, and so on. But then agentic AI being more this really coordination framework, right, across many of these agents together. So that's one of my takeaways. Now, building on that, so obviously standards deal with interoperability, but standards also will have to bring actually the scale, right? And if you are talking about agentic AI with so many agents, right, that need to be coordinated timely, then standards will have actually to bring that underlying fabric, for capacity, for latency, for reliability, right? So that actually this agentic AI at scale can happen. Right? So it's not just a matter of dealing with that interoperability, but also all what we need to put in place so that a large scale, multi, agents can coordinate together in a timely fashion and achieve one task, jointly.
Mm-hmm. Yes. Yeah, Nakamura-san?
Yeah, of course, agentic AI is a very, very interesting topic for our network revolution. But on the other hand, maybe Telefonica also, many of the operators think that we want to have a smooth migration from the 5G to 6G, especially for the core network side. And integration of this agentic AI will we would need drastic changes to our core network, and the protocol need to be changed drastically. So in terms of the smooth migration, especially at the day one of the 6G, it's a little bit tricky to introduce the agentic AI with the very big changes. But for the future, of course, this will be a very, very interesting technical topic, and we should address more seriously. And there is a possibility that the 6G day 2, we will introduce the agentic TA more deeply, and yes, with the very high performance gain.
Yeah, mainly hitting a good balance in terms of, like not disrupting the existing architecture, but still enabling, let's say, the agentic operation, right? Any further comments?
I believe that this is something that is very important here, and Patrik mentioned this before, is about which are the use cases that make sense. It's not about redefining the whole control plane to have every single function run by an agent, because right now many of the control functions are working properly, and would not make that much sense to disrupt the whole architecture. There may be use cases in which that makes sense, and not to forget about the importance of the criticality. It's something that you can say, no, well, I am using whatever the agent because I'm searching for which is the best plane ticket for my holidays.
Yes.
Well, that could be fine, but if we're talking about something that is more critical, you really need the interoperability, you really need the openness that you can get from standards, and that's where in defining those interfaces, in defining how things will become traceable, and you can assert of data quality, and you can trace back the quality of the decisions, etc. I believe that is one of the key roles of standards organizations, apart from facilitating, let me say, the distributiveness of this, not relying on a single centralized model.
Okay, focus on the higher priority aspects. I think, Patrik, you also had an architecture picture on that, right? I mean,
yeah, and
already.
One point from my presentation that, I mean, AI is evolving so quickly, standardization is much slower. Look at what AI was 6 months, 12 months ago. We will have the first release 21 in 2 years. Where will AI be then? What will be the needs for AI in 2-3 years or in 2030?
Yeah, that's basically because Anthropic doesn't need to get consensus to anyone. That's,
exactly.
In the moment they need the consensus, they will be as low as a 3GPP.
Yes, and there are competing AI companies developing these, and eventually their agents will need to interact, and they will need to join the standardization, or there will be another company developing a competing AI model. So from telecom, we can guess what the needs of these AI agents will be in 3 years, but I think we need to involve those developing AI models also.
Yeah, exactly. Okay, thanks, Patrik. I mean, at this point also we can give the chance to have like one question from the audience. If you have one question related to agentic AI integration into 6G system, you have a chance. Yes? Just at the front.
Thank you. Good afternoon. It's Monique Alissi from Martel. I have a couple of comments and one question. The couple of comments are about, let's say, coexistence of a different generation of network components, right, that need to be managed and controlled with architectures that are neither fully cloud native as of today. They are not yet AI native, and for quantum, let's talk about that in 10 years. So there is a huge challenge, I think, for the operators to control and manage a network that is so diverse. And there must be also some way in which agentic AI can provide some support in this respect. But I think a big hurdle at the level of standardization and on interoperability is the fact that there is no such a notion of a common network representation. So the trust models might be different, and until there are no standard interfaces and ontologies, it's going to be very difficult to achieve full interoperability. And then if something goes wrong, who is liable, especially in a multi-provider context? So my question is related to this. One question is about interoperability or better management from a network provider perspective of different components that belong to different generations. How you're addressing that, how do you think AI can help in that respect? And the other part is about trust models and network representation, how much standardization bodies are investing in this direction.
Yeah, thank you.
If I may, first, dealing with heterogeneity is something that network operators have been done since, probably since Graham Bell made the first connection. Seriously, we, for example, many of the, in Telefonica here in Spain, we decommissioned our last copper a couple of years ago. Now the network is fully fiber, but still we are living with ATM and things like that. And this is something that we are used to keep a certain number of balls in the air. Anyway, for sure, AI can be helpful, for sure. It's not, I'm not going to discuss this. Regarding the questions about the interoperability and ontologies, well, in particular, I would recommend you to pay attention to what we're doing in ETSI in TC Data, because this is precisely what we're doing. We are developing a methodology. Well, we have a methodology for ontologies, and we are working on that. And it's quite curious because recently, from a recent discussion in the ITF, precisely the need for having ontologies, people were, well, reluctant, because this sounds a little bit too much AI-ish and not very networkish. And now people is noticing how much things like a proper ontology can help. So it's good that you mentioned this, because it gave me the opportunity to insist in the relevance of that and in the relevance of that and in the fact that we are taking action in that direction.
Yeah. And any further comment on this question? Yeah. I mean, definitely, the existence of the different network elements across the generation is a key topic in standards. I mean, there's interworking, like this is part of the study item in 3GPP, even like considering whether they should be interworking between 4G and 6G, or is only 5G standalone. And because also like this, having non-standalone, like as a deployment creates some additional complexity, but this is something currently being addressed in also in 3GPP study item in SA2. Okay, if we come back to the slide. Can we come back to the slide? Yeah. So this is the pulse check time. So it's a question toward the audience. I mean, just to clear that it's a broadcast. So do you think the agentic AI can enable new revenue opportunity streams? We're always talking about how the operators can make additional money, and agentic AI is put like as forward network for AI and so on. As a potential opportunity. Do you think agentic AI can create revenue opportunities? If it's a yes, you can raise your hand. Okay, so I think maybe we are more into the agentic era.
Agents are cool, that's it.
Okay, so let's go to the third cluster. So connectivity or beyond connectivity, you are a bit looking into maybe the existing services in terms of in advancing the connectivity services, but especially with 6G, we started talking about beyond connectivity services. I think, Alain, you said Isaac is your favorite topic, joint communications and sensing, and then Elif, you mentioned about NTN for 3D connectivity, seamless connectivity, and so on. So the question is, what are the advancements that we should have in 6G network capabilities compared to the previous generation to enable this vision, for enhanced connectivity services and also beyond connectivity services? Who would like to take the floor first? Maybe Elif, you can take the...
Sure. Okay. I think with 6G, the goal is to really go beyond traditional communication, where the network itself senses and computes, and there's massive connectivity is made available. Research is going on in all of these things currently, while at the same time AI is also developing agentic connectivities. So all of these things will somehow shape 6G. Now, from the communication service providers or communication technology point of view, one example that I couldn't touch upon in my pitch at the beginning was this concept of access and tokens. I think there is more to think about in that direction. To dynamically distribute. For example, in NTN access right now, we are trying to think of new ways. We have a patent portfolio for NTN access, where we're trying to make sure how we can make most use of each satellite overhead pass. Just like that, for example, in LoRaWAN, which is essentially it's outside of 3GPP, but sometimes it is quoted within 6G. The concept of token has already entered it in relaying. Yeah, there's more to say, but I think I'll stop
we can
here.
see if other panelists would like to comment.
Yeah, well, I think in a way, the way I look at 6G is really the first step in that actually transition of the communication network being a connectivity fabric to becoming an intelligent platform, right? And to become an intelligent platform, it means you need actually to add capabilities, platform capabilities. Certainly data is key here, but data we can get it actually from multiple sources, whether it is satellite, it is cameras, it is sensing capability, LoRa sensors, whatever, right? So having actually that ability to collect the data, integrate the data into the network, making sure that this data actually can be, if you like, made a good use of both inside the network and outside the network, to me is the biggest important capability that we need to kind of achieve into 6G, right, in a nutshell. Now, certainly, back to the comments on the tokens, so what attracted my attention now, if you check all these companies working in AI, so they all actually project the future or forecast the future by putting huge numbers and trillions of tokens, right, that we need, that eventually data centers or other kind of, fabric will have to accommodate. So I haven't seen yet, to be honest with you, any kind of similar forecast as to what is it, the scale of these tokens that we need to be supporting in a 6G system, right? Yeah. One example I was reading about recently was like, in a sense, an AI agent actually would consume 1 million tokens typically, right? So imagine yourself actually, again, back to the previous question, an agentic AI with so many of these tokens. So basically, having the ability to transport tokens and have the assurance of the tokens and the ability to monetize and build these tokens, actually making that transition from bit and bytes up until now to tokens, whether it is for the automation of the network or the support of the AI traffic, is a major capability that we need to be building in the 6G system.
Quite a mindset shift again, right?
Yeah.
Yeah. Any further?
Yeah. Originally, I did not intend to answer this question, but I really want to say something about this. Yeah.
Don't hold yourself.
Now, as I mentioned, the network architecture itself, we don't want to have a drastic changes, especially for the day one of the 6G. yes, for the smooth migration from the 5G to 6G. But on the other hand, the NTN, NTN is a very good advanced connectivity topics, and there is a good possibility to create a new services, new revenues for the operator point of view.
Okay.
And we are very aggressive for the NTN, of course, and especially for the hubs. And the hubs case, not only the connectivity, but also the hubs can implement a variety of the sensors, including the cameras. And getting the image of the cameras or the videos, that can be utilized for the variety of the services for the agriculture or defense or many things.
Public
And,
safety.
that could be a good new services, revenues for operator point of view. So that is maybe beyond the connectivity services. So, yeah.
Okay, yeah, thank you very much. So maybe at this point, we can also take one question. Yes, there. Do you have the microphone?
Yeah, thank you very much. This is Michi-san with the Next Generation Alliance. I think this is a great question because starting this week, I've been thinking about what kind of future role for operators, right? So I think that for operators, you are in the fork role to decide what you want to do next. Because Alain, you mentioned that now the traffic is from data to token, and bit by the token. But depends on what kind of role you're thinking. If you still want to be a big pipe, token is the data, data are data, right? So that on that road is not going to be changed too much. And I've been trying to study AI for some time, but finally I decided I want to stop for a while because I want to let the bullet fly a while. Just the term agentic AI. I've run into a problem that is agentic AI on the service and application layer of agentic AI, or it's like a part of the network, right? That's something we need to decide. If that's on the service level, it's just the bits and bytes. So it doesn't really affect the network nature today. On the other hand, based on this question, I'm also thinking that is operator are going to maybe modify your pipes in the future, become pipes with all the characteristics. One pipe for hubs, and one pipe for some other services, so that you can actually kind of make the whole environment more dynamic, and then we can take the best advantage of the AI in the network.
Thank you for the question. Maybe we can give the floor to operators here. Nakamura-san, you want to take first?
Yeah, that's true. You point true. And we should prepare the variety of the pipes, of course, to treat the data as much as possible. And not only the human communication, but also the physical AI will come, and IoT services will come more. So a variety of data we need to treat. So for that, the variety of the pipes should be used, but the integration is very important. Yes, how to integrate the variety of the pipes that need to be standardized, and I hope that we can implement rather easily, supported by the vendors like you.
Any opinion, Diego, on this?
Well, basically in this, I believe that operators should not fall is in the trap of trying to cover again the whole stack. There are other actors in the service environment, and the idea is to collaborate with them and provide the mechanisms for enabling this in both sides. Because something that is become, so in my view, more and more important, is that the highly centralized provider-consumer relationship that we have now is going to change. More people will be acting as micro-producers or micro-providers, if you like, and we are in a very good position for facilitating this. That at the end, if you look at it at the very, very, very micro level, we're talking about connectivity, but we're talking about so many different kinds of connectivity that we can talk about going beyond connectivity, or at least beyond the current connectivity. And I think there are quite interesting opportunities there if we are smart enough to catch them.
Yeah, thank you. I think that also echo your earlier question about the opportunities for making more revenues. Because if your operator's structure is still based on the pipes, then the only way you can get more money is actually make more subscriptions.
Yeah.
Right? So if you treat the pipe the same, then you cannot do that. But on the other hand, now all of a sudden as an end user, I have multiple pipes, different kind of pipes at my choices. That will be a different world, right?
Yeah.
Okay.
That's challenging because you're right. The whole structure of the companies is very much focused right now on subscriptions. And this is something that is challenging, but at least from the side of the technology, we should try to provide the means for changing this. Yeah. Totally agree.
Thank you. Thank you very much. So also now the pulse check time. Okay, it's not only related to this area, but overall, so far what we have discussed. So do you think 6G shall be, the A group is 6G shall be a smooth evolution of 5G? Any response? Okay, quite. And what about the B group, that 6G shall be as disruptive as possible? Any, okay, maybe I don't know, it's a split between academia and industry.
Based on everything we discussed, I think I would go as far as to say that 6G has to be disruptive to provide profits, to be successsual. Otherwise, money is going out of the
but the problem is that when we're talking about disruptive, is what you're
Disruptive in a
intending to
good way.
disrupt. No, that's exactly that.
Yeah, maybe A should be a day one, B should be day two.
Yeah, right. Okay, so we don't have so much, time, but I am at least maybe we can have some discussion on the edge because. You know, when we also were discussing about 5G, all the integration of the verticals, industrial communications, vehicle to X, and so on, you know, like we said, edge will be very important, and it will be used for autonomous devices, you know, autonomous vehicles, and so on. And in 6G time, of course, we have quite some focus on AI adoption, but we are also still we are talking about also some time-critical applications and so on. So would we say that edge computing would really fly now with the 6G era? So how is your take about the role of edge computing in 6G? Maybe we can talk very brief answers because we are coming to the end.
Yeah, I believe definitely edge computing will have a potential to play a big role in 6G. The question is how far out into the edge you're talking about. Should you place processors out in every base station, or is it more in central cloud? And since it's very mobile users, you need a lot of processing in every base station. So I believe more in central cloud. But this will enable a lot of offloading for more lightweight devices, XR devices, and offloading AI processing for autonomous or physical AI, for instance.
Yeah, how deep the question is, right? Any further comments on that one?
I can maybe chime quickly on that. Actually, from a discussion with a colleague this week, it was insightful to appreciate that edge can go as far as eventually 100 kilometers in the network. Because I think some people might consider edge to be like in a 5-10 kilometer, no more actually than that. And having that appreciation shows that edge role is going to be even more critical in the 6G system because edge will allow that compute, significant compute capability embedded within the system, right? So this is really critical. And up until now, we approached edge more from the application standpoint that we would like actually to run the application with low latency. But this is also changing in the way we look at edge and 6G because we are approaching it more from the data standpoint and the AI traffic standpoint, the fast inference, also the data governance, right, and all this. So the role is going to be even more critical, I would say, to edge, and importantly, edge spanning, a significant, mileage, if you like, in the infrastructure.
Indeed.
Well, in some cases, edge computation is necessary. For example, for multi-agent operations, right, or federated learning. And it's the only way in some cases. So what, how the operator can come in, I don't know. It seems to me that the more edge computing, the less business for the operator.
Why?
Is it? No?
No. I think somebody was talking about in-network computing.
Not necessarily at all.
No?
No, that's no.
In-network computing.
I mean,
Nakamura
operators don't work only long haul. We have, and one of the main advantages of operators that are being well established is that you have a high, which is the name, pervasiveness in the so we can take advantage of this.
But I'm talking about very, very edge, like next to the device.
Well, that depends. I mean, we have a business unit that is working on that.
Yeah, I think in the keynote, there was that Telefonica was planning already 17 edge computing sites and so on, right? That
So if we're talking about moving things, I mean, we're talking about the device. We're talking about, no, I have my mobile phone that is provided by whoever. I don't care about privacy. I don't care about anything. I'm happy with my mobile phone. Well, then it's another story.
Okay.
But it's at the edge. Well,
Yeah.
up to you.
Now we are standing just
Where do you put? You draw
at
the
the
line.
coffee break. Maybe I just do the pre-coffee break pulse check. So that is, I mean, in terms of the edge computing, do you think 6G, finally in 6G era, the edge computing will be effectively adopted and utilized? If you think yes, maybe you can raise.
Who knows?
But there are quite some believers, right? All right. So with that, we are just on the hour. So I'd like to thank my fellow panelists for being here and the full crew answering the questions and also replying to the pulse check as well. So thanks for engaged audience. And with that, I think we can close the panel and we can go for the coffee break. So thank you very much.
Thank you.